Hello friends, now in this video we are going to discuss about the different cases in polar form of complex number, and we will give some illustrations for this purpose. Here you can see 4 diagrams. The first diagram, we have taken a point P on the first quadrant. So in this case x is positive, y is positive, and it is in the first quadrant. And O is the pole, OP is a modulus, and it makes an angle, say, phi. Phi is an acute angle. And theta is amplitude of Z. Here theta lies between 0 and 90 degrees. And the angle here is phi, so amplitude theta is equals to phi. And you can write the polar form of Z is equals to R cos phi plus I sin phi. Now in the second diagram, the point lies in the second quadrant, so its coordinate is minus x comma y. So here Z is equals to minus x plus IY. Now OP is equals to R is equal to mod Z, and here the angle is, if I mark this as phi, so theta is equals to pi minus phi. So Z is equals to R cos now the cos theta plus I sin theta, and in this case we will write R cos of, now theta is replaced by pi minus phi plus I sin pi minus phi. So when any point lies in the second quadrant, their polar form will be in this form. Now we'll go to the third one. Here the angle in the third quadrant, so Z is equals to minus x minus IY. And in its polar form, the modulus is R cos theta plus I sin theta, where theta is the amplitude. Now what is the value of theta here? Theta, actually angle is from here, but numerically we will move from this to this one. As this one angle is phi, so this will be minus of pi minus phi. So R cos minus of pi minus phi, I sin minus of pi minus phi. In the last case, Z lies in the fourth quadrant. Here x is positive, y is negative. So z is equals to x minus iy, and its polar form r, and this is minus phi. Cos of minus phi I sine minus phi. So here we are getting 4 cases. First one, when theta lies in the first quadrant, z is equals to x plus iy. Here both x and y are positive, and amplitude theta is an acute angle less than 90. And if we mark this angle is phi, we got theta is equals to r cos phi plus I sin phi. In the second case, when z lies in the second quadrant, it is in the form z is equal to minus x plus iy. So here z is equals to r of cos theta plus I sin theta. This is the polar form. But here the theta is this much, and which is equals to pi minus phi, where phi is an angle less than 90. So it becomes in this form. Now in the third case, when theta is in the third quadrant and z is in the form x minus iy, here the polar form where r cos theta minus I sin theta. Now theta here consider minus of pi minus phi. So theta is replaced by minus of pi minus phi, and so we get the polar form r into cos of minus pi minus phi whole, and then I sin pi minus phi whole minus, and then lastly fourth quadrant, it is in the form x positive but y is negative, so x minus y by. So polar form r cos theta plus I sin theta, it becomes cos of minus phi plus I sin of minus 1. So here theta is equal to phi. Here amplitude theta is equals to pi minus phi. Here amplitude theta is equals to minus of pi minus phi, and here amplitude theta is equals to minus phi. Okay. Now we'll give some illustration. Find the polar form z is equal to 1 plus I. So here x is equals to 1, y is equal to 1, so both are positive. So it is in the first quadrant. First we'll find R. Root over x square plus y square, and here x is equal to 1, y is equal to 1. So 1 square plus 1 square is equal to root 2. Now we'll find theta. First we will find phi tan inverse mod y/x. Tan inverse, here y and x both are 1, so tan inverse 1, that is tan inverse 1 is tan of pi by 4, so the value is 4, therefore amplitude of z is equals to pi by 4, and polar form r cos theta pi sin theta, r is root 2, then cos, now theta is pi by 4, pi sin pi by 4. Now illustration 2. Find the polar form z is equals to minus 1 plus I. So here x is negative, y positive, so it lies in the second quadrant. So first we'll find r is equals to mod z is equal to root over x square plus y square. The value of x is here minus 1 and y is 1. Root. Now pi tan inverse y by x, tan inverse x is minus 1, y is 1, so 1 by minus 1, tan inverse mod of minus 1 is equal to tan inverse 1 is equal to pi by 4. Now amplitude theta is equals to amplitude z is equals to pi minus phi is equals to pi minus pi by 4 is equals to 3 pi by 4. So polar form of z is equals to minus 1 plus I is equals to root 2 cos 3 pi by 4 plus I sine 3 pi by 4. Our next illustration is find the polar form of z equals to minus 1 minus I. So here also x is equals to minus 1, y is equals to minus 1. So first modulus x square plus y square. Here x is minus 1 whole square, minus 1 whole square, 1 plus 1 root 2. Now phi is an acute angle. The value of phi is tan inverse mod y by x, tan inverse, both are minus 1, so tan inverse 1, pi by 4. Theta, amplitude of z, so in this case amplitude is this much, which is equals to minus of pi minus pi. So here minus of pi minus pi by 4, which is equals to minus 3 pi by 4. So polar form root 2 cos minus 3 pi by 4 plus I sine minus 3 pi by 4. Now our last illustration, find the polar form complex number z is equals to 1 minus I. So here x is equals to 1 positive and y is equals to minus 1 negative. So the point is on the fourth quadrant. Now R mod z, x is 1 minus 1, 1 plus 1 root 2, 5 tan inverse minus 1 by 1 mod of minus 1, 1, 5 by 4. Therefore theta is equals to, that is amplitude z is equals to minus 5, equals to minus 5 by 4. So polar form minus 5 by 4. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.